Okie doke, we are into 10.2 and we're just going to deal with sequences in 10.2. Then we're going to go to 10.3. We're going to deal with what's called a series, which just means we're going to add up the terms of a sequence. Let's jump into it. So we're going to get you two theorems right off the bat. Theorem 10.1, limits of sequences from limits of functions. Well, all right, so suppose f is a function, go with some a sub n, for positive integers n, right? Remember, n is equal to 0, 1, 2, 3. But this is just saying 1, 2, 3, 4. Only positive. If the limit is x tends towards infinity of f of x equals L, then the limit of the sequence a sub n is also L, where L may also be positive or negative infinity. Which means the last thing we did in the last video, where I just did the limit and treated it as if it was just x's, like the way we've been doing limits in Calc 1. That's exactly what we're about to do here. Now, it also gives us our rules, our limit laws for sequences. Dude, those are the same exact limit laws for just regular-ass functions that you learned in Calc 1. So if we have a firm understanding of how to do limits from Calc 1, this is not going to be that challenging. If you do not have a firm knowledge as to how limits work from your previous class, good luck. Good luck. I hope you took on-ground classes for your other classes, or you paid attention. Or you have a memory that's better than mine, because I forget everything. Teach me something, ask me about it next week, and I won't remember anything. So let's jump into these problems. A lot of talking, but I think it's good for us to see something. So I want to know, where is the limit of this sequence? Where's it going? Where are we going to end up? Does it go to a number? Does it diverge? But I want to actually know the number, whether it's infinity, 4, 7. So we're going to, on these three problems we're about to do, we're going to determine the limit of the sequence. So we want to just look and see, all right, cool. Where the limit is n tends towards infinity as to how we do this. But what this is saying back up here, where it's like, well, just do it for f of x. Like f of x? Well, we could write it this way. The limit is n tends towards infinity of 5n squared plus 3 over n squared plus 2. Well, we could say this is the same thing as the limit is x tends towards infinity of 5x squared plus 3 all over x squared plus 2. Just change the letters. Now, what's different about this? This is not continuous. Right? Because we have these numbers. 1, then 2, then 3, then 4. Where when you use x's, these are continuous, right? There's a number in between 1 and 2. 1.5. 1 1/3, 1 1/4, 1 1/5. There's infinitely many numbers in between. So we're going to treat it as if they're x's. But we don't need to write it as x's. We just leave it as n's. And we do work. Now this problem, if you have taken a Calc 1 class, you should be able to just state the answer. The answer is 5. The degree of the top is 2. The degree of the bottom is 2. I don't think adding 3 to infinity is going to do anything. But, again, if you don't like logic, you like doing extra work, go for it. We'll say L'Hopital's. All right, cool. Take a derivative up top. That's 10n. Take a derivative down below. That's 2n. The n's cancel. You have 10 over 2, which is equal to frickin' 5. You should just be able to look at that and find the answer. When you take tests, dude, while you're having to write out 5 steps just to figure out where the limit goes that you should be able to look at and find the answer, your classmates are just stating the answer and going through, and they might actually finish the test, because Calc 2 tests, as you know. Man, there's a lot of material, and you got to work quick. So there we go. We found the limit of the sequence. It's 5. Let's go to another one. All right, b sub n is equal to n plus 5 over n, all raised to the nth power. This is going to be another example of, do you recognize it? Because if you recognize it, you can just state the answer from Calc 1, previous class, or you get to do a ton of frickin' work. So we're going to want to take this limit, but I want to change it up a little bit. You see the single term down below? Let's write it a little different. You know what I mean? It's n over n plus 5 over n raised to the nth. So this is b sub n is equal to 1 plus 5 over n raised to the nth. Wait a second. Don't we have a formula? I'm pretty sure we do. I'm pretty sure the limit as x goes to infinity of 1 plus any number over x to the x is equal to e to the a. We've seen this, haven't we? We've seen this before. So you could just state the answer, say it's going to e to the fifth. If you don't recognize it, wow, do we have work to do. All right, so let's set it up. We're going to be like, all right, so we're going to take the limit as n tends towards infinity of 1 plus 5 over n to the n. Now, if you stated it, if you just looked at this and went, dude, I know the answer, it's e to the fifth. Just state it. It's all good. Our tests are on ground. I'm not concerned that you're just looking at the internet. That's knowledge. Once you've learned something, why the hell would you do the extra work? But it's up to you whether you want to do that or not. So the way this works is we're going to hit it with a log, but this kind of turns into something crazy. We're going to say that, well, e to the ln of our b sub n. All right, isn't that going to happen? That our b sub n here is... no, it's 1 plus 5 over n to the n. So then the n falls and we get e to the n times ln of 1 plus 5 over n. And then we call this, we're just like, well, let's just call this L. And then we'll solve this limit. You remember this? Do you remember this? I mean, you took Calc 1, right? You passed it. You got to remember seeing this. So we're going to solve for that L. We're not going to solve for that part. So here we go. Did you know that n is the same thing as 1 over 1 over n? If not, and you don't recognize the pattern, you were pretty hosed. So let's make sure we're on it. So we get ln of 1 plus 5 over n over 1 over n. Oh, did I forget something? You should have been yelling. It's a limit as n tends towards infinity. L is a limit as n tends towards infinity. Now we can do it. Okay. Well, let's look up top. It looks like we have a 0 case, right? You plug in n goes to infinity. You have ln of 1. We all know that's 0. 1 over n as n tends towards infinity. That's 0. So we have a 0 over 0 case, which means low p talls. Dang, it would have been so nice if we just recognized the pattern. But let's just keep going. Let's just keep going. So we're like, low p talls. Here it comes. Limit as n tends towards infinity. I'm going to go quickly because we already passed this class, right? We already passed this class. So this is 1 over 1 plus 5 over n, right? The derivative of ln of blah is 1 over the blah times the derivative of 5 over n, which is negative 5 over n squared. Now let's take a derivative down below of 1 over n. That's just going to be negative 1 over n squared. Well, look at that. The negatives are going to cancel. The n squareds are going to cancel. Only thing we are going to be left with is the limit as n tends towards infinity of 1 over 1 plus 5 over n times 5. Well, we all know this trick from Calc 1. If n's going towards infinity, that just goes to 0. So it looks like we have 1 over 1 times 5, which is equal to 5, and we just found L. L is not our answer. We need to plug it back in at the beginning and go, oh, this is equal to e to the L, e to the fifth. And we found it. Wouldn't it be so nice if you recognized the pattern? You didn't have to do any of that work. But it's up to you whether you recognize patterns or not. And let's go to our last one. Oops. Oops, oops, oops. There we go. C to the n is equal to n to the 1 over n. Cool. Cool. Where's that going? I don't know either. So we're going to take a limit. Actually, I do. I'm such a liar. I'm sorry. Of n to the 1 over n. Now, there's not much we're going to really be able to do here. We're forced into it. I don't just see this one and go, oh, clearly it's equal to. I don't freaking know. Lies. But I wouldn't have first, but we have a variable in the base and we have a variable in the exponent, which means we need to do that e to the L trick. So we're going to say, well, e to the L would be equal to e to the ln of n to the 1 over n. So we're just going to say our L is equal to 1 over n times ln of n. Oh, I keep forgetting to write that in there. Oh, I'm so sorry. I'm so sorry. It's the limit as n goes to infinity. This is the limit as n goes to infinity. Oh, there we go. So now let's find what we have. Well, we have our ln of n up top, and then we have the 1 over n. So, oh, there we go. This is an infinity over an infinity case. It's not equal to it, but it's infinity over infinity, which tells us L'Hopital's. Let's go. L'Hopital. The limit is n to infinity, so the derivative of ln of n is 1 over n. The derivative of n is just 1. That goes to 0, so L is equal to 0. But that's not our answer. We got to take that thing, we got to pop it back up and go, whee, pop it into there. It's going to be e to the 0th, which is equal to 1. Oh, man, it looks like if we don't know how to do limits, we don't know L'Hopital's, we don't know the stuff that we learned in the past class that we passed, we're hosed. Limits are back, y'all. I hope you recognize some patterns. That'll make life a lot easier. All right, done babbling for this one. I'll be back to babble on some more.